Hello folks, welcome back. So we're getting into chapter 2, which covered how to get to know your data, what frequency distributions are, rates, percentages, percentiles, and how to visualize data in order to explore it. We call this data exploration to really understand how different variables are distributed and such. So let's get right into Stata. We're going to open up the GSS 2016 as the Chapter 2 tutorial indicates. I'm also feeling like playing some music. It was just Harry Potter's birthday, so I'm inspired. Hopefully this doesn't distract you. All right, I have some music on in the background now. So let's open up GSS 2016, and as I've asked a couple of times now, hopefully you've already downloaded the data set, all of the data sets from the textbook website, so you have them easily available. In my case, I've created this folder for this class, 318, and I have a textbook data folder where all of the data sets are for the entire textbook. And so I'm going to double click on GSS 2016.data. I always forget that I have a Stata 13 version, so I actually need to right click and open with Stata 15. I have two different versions of the program running. You shouldn't have that problem. You should be able to double click and open up the data set. Okay, so we've opened up the GSS 2016 data set, and ooh, we're not in Kansas anymore. We've got lots of variables here. Unlike chapter 1, we only had, 6 variables and 10 respondents? Here we've got lots of variables. So let's just browse really quickly and see how many variables. 983. Can you imagine being a respondent on a survey with 983 questions? And 2,867 people that responded to this. So the General Social Survey is one of the largest social science data sets. It's asked of many thousands of people. It's replicated over many years. So there are multiple waves. This is the 2016 wave. And it asks so many interesting social science questions, or sociologically relevant questions that social scientists care about. All right, so we know a little bit about the data set now. I'm going to work directly in a do file, and I encourage you to do the same, even though you could just type the commands here as we did with browse. Ugh, YouTube ads, are you kidding me? Okay, excuse me. So another one, wow. All right, that was distracting. I apologize. Okay, so moving forward, you could just type it into the command box, but we're going to get in the habit of using do files. How do you do that? You go up to Window, do file, create a new do file. Notice the do file has this line here. That's intended so that you can keep your code, even though you could make it really, really long. Having the do file window open at the same time as your Stata window and docking them on different parts of the screen so that you can have easy access to both at the same time it improves workflow. So we try to keep the do file this small and try to keep our code approximately up to this line so that it doesn't start getting too long. Okay, so the first thing we want to include in our do file is this use with the data set path, the full data set path, and that will tell the program to open up this data set. We've already done that. We already have the data set open, so we don't actually need to run this in the do file, but we always want to have that listed in the do file. What have we run? Okay, and I'm going to include a comment at the top of the do file indicating what chapter this do file is for. Chapter 2. I've told the program that this is a comment as opposed to a command by having an asterisk in front of the comment, and you'll notice that the comment is in green, the command itself is in blue, and then the file path is in red. So Stata makes it really handy and easy for you to identify what is a command, what is a comment, just by color coding it. All right, so we've opened up the GSS data set. We browsed it and saw that it has tons of variables and respondents. Now let's get into a little bit of data analysis. So for this tutorial, we're interested in only 3 variables. I'm going to write them here at the top so that we remember what they are. PA degree is the father's highest level of education as reported by the respondent to the survey. MA DEG is mother's highest level of education as reported by the respondent, and age is a variable just asking the person, how old are you? And it is an interval ratio variable. Excuse me. And how do we recall the level of measurements? Well, we'll talk about that in just a moment. I'm going to comment all of these out so that the program doesn't think that I'm trying to use those as commands. Okay, so we have father's degree, mother's degree, and age. As a side note, you can type these in here if you wanted to easily find that variable. You have this filter option. Once you start typing in abbreviations, it will pare down the list of variables to help you easily find it rather than having to scroll through by hand, which with 900 and some odd variables is quite impossible. All right, so level of measurement, why does it matter? Well, let's first do a couple of really basic exploratory analyses on our variables. Tabulate PA degree. What has tabulate done? Oh, I shouldn't skip this. Notice that I just highlighted this line of code. You can do that by double-clicking on the line where that code is. So I clicked here on this line, that highlighted it, and then I went up to execute selection. I could have just as easily written this into the command window directly, but then you would have to copy and paste it back into your do file, which is more effort than just writing it directly into the do file and using the execute command. Okay, so tabulate PA degree. What has this done? It's created a table for us that gives us the number of people that responded, the total number of people that responded to this question, 2,169. And remember that when we went into the browse, we know that there are 2,867 observations. So we know that we're missing some people from this question, and we'll address that in just a moment. And of those 2,169 people that responded to this question, here's the breakdown. 663 of them reported that their father's highest degree was less than high school. 1,010 of them reported that their father achieved a high school education. 64 of them reported that their father achieved junior college, and so on. Then it gives you the percentage for each of these, which is super handy because we don't really care. Not that we don't care, we actually very much care. If this was a cell that had 0 or only 3 respondents, that would be a red flag. But we also want to know, in addition to how many people responded to each of these categories, what's the percentage breakdown? So of these 2,169 respondents, what percentage of them report that their father had a bachelor's degree or higher? So that we would get that by adding 12.5% to 7.3%, and that would be people who report that their father has a bachelor's degree or higher. If we want to know just the percentage of respondents whose father have a graduate degree, that's 7%. Or just the percent of respondents whose father have less than a high school degree, that's 30% of the sample. All right, what we normally want to do with a tabulate command, however, is to add this option missing. So when I add this and then highlight by clicking over in the gray area and then clicking on execute selection, notice what is different here when we've added the missing option to the tabulate command. It gives us this extra category at the bottom that is this period. If you recall from a previous video, this period is denoting missing responses. So 698 people, which represent a whopping quarter of the sample, did not respond to this question. So they didn't respond to this question at all. That's a large percentage of the sample, so we might be particularly worried that these people have similar characteristics to one another, that they're not missing at random. So we always want to include missing with tabulate so that we can see the percentages of all of the respondents and the percent of the data that's missing on a particular question. The other thing that's useful when we're running tabulate is including a no label option. The no label option, I'm accidentally putting bookmarks here. These little blue arrows are bookmarks, and sometimes they're useful, but right now I'm doing it on accident. You can ignore them if you happen to do the same. So the no label option, notice, will give you, instead of the value label for each of the response categories, it gives you the actual code value that category is associated with. So for example, those who reported less than a high school degree are coded as 0. Those who reported that their father achieved a high school education are coded as 1. Those who reported their father achieved junior college are coded as 2. How can I verify this? Well, JC has the 64 respondents, and here that 2 is the 64 respondents. Why do I care about these values? Well, we're going to do some recoding of variables in a little bit, and when you recode, you have to know what these values are, not just what the label is. Both of them are really important, though, because you might see how if you didn't have these labels, you might get really confused which categories are which, since you didn't create the data set and probably don't know what the general social survey coding is off the top of your head. Shame on you. Just kidding. All right, so let's go ahead and tabulate now the mother's highest education and see how it compares to father's. So we can really easily copy all of this by highlighting it and clicking Control-C on a PC, and then Control-V to paste. If you learn nothing else in this class, a few keyboard shortcuts make all the difference. And then we're going to change all the PA degree to MA. Okay, so we're going to highlight all 3 of these and then click on Execute, and you'll notice the results pop up in the results window. You'll also notice that it tells us where we started running the do file. And we can now compare for mother's degree. Notice 2667 responded, as opposed to father's highest degree was 2169. So we've got lots more people who know their mother's highest degree or who care to respond to this question than they do for father's highest degree. Only 200 people didn't respond to the mother's degree question compared to the 700, nearly 700 on the father's degree question. And the coding is the same, and we can see that both from the value labels and the values themselves. And let's see if the distribution is different. Do people report that their mothers attained a higher education or their fathers? I think you probably have some intuition about this. Let's see. So In terms of less than high school, 25% of the sample reports their mothers achieved less than high school. 47% report that their mothers achieved a high school education. 5% report a junior college, and 10% report a college degree. Let's just look at the less than high school, comparing this to the fathers' data. So less than high school for mothers, that's 27% of the sample. For fathers, that represented 23%. High school education, 50% for mothers and 35% for fathers. And looking at the top category, graduate degree, 5% of respondents said their father had attained a graduate degree, and approximately 5.5% for both, for mothers. The cumulative percents are even more helpful because you can see what percentage achieved a particular level or less. So we might say, for example, for mother's degree, 78% of respondents report that their mothers achieved up to a high school education. So up to a high school education. For men, 60% report that their fathers achieved up to a high school education. What does that tell us? Well, people are more likely to report that their fathers had a higher degree than their mothers. And the missing data is very interesting. People are more likely to skip the question about their father's education than about their mother's education. And we might hypothesize that that is because of potentially people raised by single parents, and single parents tend to be mothers. So maybe those folks refused because they don't know what their father's level of education is. Okay, so we've taken a look at mothers' and fathers' education, and let's say we don't need to know all of these distinctions. What we really care about is the distinction between just a few of these categories. And we want to recode the mother's educational variable so that we have three categories instead of these 1, 2, 3, 4, 5 categories. So we want to recode these 5 categories into 3 categories, and to keep the missing data missing. And then we're going to have categories that look like finishing high school but no further schooling. Oh, hang on a second. I'm going to pause here for a minute. Okay, I'm back. Sorry for the intermission there. I realized that I didn't know exactly which of the 3 categories we were going to use to recode, and needed to clarify that, and that led me to go have some rice for lunch. So sorry for that digression. Let's move forward with the recoding. So we want to change mother's degree to have 3 categories, and those are less than high school or high school. So we're going to combine these 2 categories, the less than high school and high school. Then college, some college but didn't finish college, so we're keeping the junior college as its own category. And then college or higher, so we're going to combine the bachelor's and graduate degree. Why does this matter? Well, sometimes we don't need all 5 categories. Sometimes we think the difference is really going to be between those who graduated college versus those who didn't. Or in this case, we think that there's going to be a substantive difference in whatever dependent variable we're interested in between people with high school or less versus some college versus college or more. So essentially, we don't need these as many distinctions as we have here. So we're going to create a brand new variable by using the generate command. That creates a whole new variable. we type in generate, and we're going to give it the same first few letters, and then we're going to add recode so that we know that this is a recode of the original variable. And we're going to make the new variable exactly equal to the old variable, which we're going to change in just a second. You might wonder, why am I going to create a variable that's exactly the same as the previous one? Well, that's how we start, so that we maintain all of the missing data in a missing category, and then we're going to recode the variables that we've got up here. So once we use generate, we're going to add recode, and now we're recoding this new variable that we just created, which we called MA DEG recode. And the recode syntax works by telling the program first what the old value is and what we want to make it. So we said we're going to combine the 0 and 1 category. We're going to leave category 2, and then 3 and 4 are going to be combined. So we're going to recode what was formerly coded as 1 is going to be coded as 0. So 1 equals 0. Then what was formerly coded as 2 is going to be coded as 1. And what was formerly coded as 4 is going to be coded as 2. And then we're going to want to tabulate the old version of the variable and the new version of the variable, just to make sure that we achieved what we thought we were going to achieve. And we can also tabulate the new version and make sure that the missing data remained missing. And none of this has yet been executed by the program. We need to highlight this code and then click on the execute selection. And here you'll see in the results window, this is where we ran the do file, and what that did was run the generate command where we created this new variable. New variables are added at the very bottom of your variable list. So here you can see the recoded variable we just added. Then it recoded immediately to have these new categories. And here's where we can check whether we achieved what we wanted to achieve. And I think I missed something. Yes, I missed something. So this is why we do the tabulate the old version and the new version of the variable. Although you would have seen this here too. You would have gone, oh wait, but we still have this category 3 that we actually meant to combine previously. So what we were trying to do was have the college and graduate school be combined. So we should have had 292 plus 146 as our third category, but you see that these two did not combine. So what did I miss here in my recode? I should have said 3 and 4 are going to be equal to 2. So it's telling Stata that both the number 3 previously and the number 4 previously are going to now be coded into 2. So since I've made this mistake, the best way to handle it is to delete the new variable that we created and then recode, run the entire generate code and recode again. So the way to drop the recoded variable or to delete it is called drop. And we can drop MA degree recode. I type that into the command window since that's not a command that I want to keep. Although I could include it here with an asterisk commented out so that I remember that ME degree recode. I remember that that is how to drop a variable if you wanted to annotate your own Stata file. Drops variable, drops or deletes. All right, so I've dropped the variable. Now I can rerun the code now that I've cleaned the error in it. And now we see that it did what we wanted it to do, which is have only 3 categories, combining the less than high school and high school together. And we can look at this cross tabulation, which compares the old variable and the new variable to make sure that we've achieved what we wanted to. So here's the old variable with all of its categories. And we see that in the old variable, the 736 and the 1349 respondents who reported less than high school or high school are now coded as 0 in the new variable. Then who's coded as 1 in the new variable? Just these 144 people who reported junior college. And who's coded as 2 in the new variable? Bachelor degree and graduate degree. And again, remember these are people reporting their mother's highest level of education. Okay, so this achieved what we wanted to do with recoding the variable. Now let's get on to visualizing some of the data. Oh, actually, we need to add variable labels. So now that we've generated this recode, we should add a label, a value label to each of these so that we don't get confused what the 0, 1, and 2 means. So now that we have this cross tabulation here, we can easily remember what we did. We combined less than high school and high school. We left junior college, and we have bachelor and graduate combined. So we're going to tell the program to give this new variable MA degree recode to give value labels to each of these 3 values so that we then see it the way that we see the labels up here for the old version of these variables. Okay, so how do we do that? We're back in our do file. We're going to define a label using label define. We'll call it degree. That's going to be what the value label is called. I always like to include an underscore LAB for label so that I know that that's not a variable name, but rather a value label name. And then we first list the value, in this case start with 0, and then we'll tell the program what the label should be for 0. High school or less. Then 1 is some college, and 2 is bachelor's, say college or higher, or bachelor's or higher. And the second line that always goes along with label define, because all we've done here is told Stata to store a value label that's called this. Then we need to tell it label the values of this variable, MA degree recode, with this label here that we just created. So these two together, we highlight and execute, and notice that even if I only partially highlight the lines, it will execute the command anyhow. Looks like nothing happened, but if we now tabulate the variable MA degree recode, you'll see that it has labels. Yay! And if we wanted to go back to seeing what this looks like without labels, you just add the no label option or no lab. There are a lot of abbreviations that I might tell you or might not tell you about. If it's more cognitive effort for you to remember the abbreviation than it is the full syntax, then don't do it. But if it makes it easier for you and you are able to remember, then you're welcome to look up and use abbreviations. All right, so we've recoded this. We're gonna hit pause and come back for part 2 in generating some graphical representations of data. Woo woo.